Alrighty. Good morning, everyone. Welcome to the final workshop of SoccerBot. This is Software 2. We're going to be going over a lot of fun stuff today. So for today's agenda, you have to go to this one. So for today's agenda, we'll be going over the main code that will be finally powering your SoccerBot. We're going to go over some competition logistics, and then finally, we're going to be helping all of you catch up, make sure your robots are working for the competition.
All right. Now, I'm gonna go over the main code that we're gonna upload onto the card today, and I think it's pretty simple if you follow us during our first software workshop. And yeah, let me share my screen. So first, I'm gonna talk about the flowchart, which is basically before talking about the code, so that you can have a main idea of how the code operates. So in general, so inside an Arduino program, there's a function called loop, and a function called setup. So when the Arduino program starts, it's going to run through the set of function once, and then it's gonna run through the main loop function continuously, over and over again. So this is the flowchart for the main loop function, which the Arduino constantly running. Okay, and then in this main loop function, we have three main components. So first is the speed control, where it's basically receive the input from the receiver or controllers, and then adjust the speed value within the Arduino software, and then send it out as an output signal to the driver from the Arduino. And then next we have the direction control. Again, receive direction input from the receiver, and then adjust the software values, and then send it out as the output from the Arduino to the driver. And the last part of the code would be the motor updates, which is basically updating the value being changed during the first two functions into the actual pins of the Arduino, so that it can output again to the driver. So that's the three main functions of inside this main loop functions. And I will talk first about the speed control function or user-defined function within this main loop function, and then we'll go over the direction control as well as the update motors functions. But before that, I would like to go over the code first. So yeah. So here's the code for Arduino. So the first thing to do in every Arduino program is you define your variables. And in this case, we have a lot of different variables. Mainly the pins name, the variable for the pin names, and the variable for some of the software flags that we're gonna use. Okay. So first, we have integer a duty cycle variable, which is basically the variable to control the duty cycle, sending out by the analog pin for the PWM signal. And this variable will basically control the speed of your motors driving the car. So the range of it theoretically will be between 0 and 100, and it will increment in term of 10, so 0, 10, 20, 30. And then if you see on your controller, there's up and down button. So in our software, if you press the up button, it's increment by 10, and then you press the down button, it's gonna decrement by 10. And how exactly we're gonna do that, I will go over that later. And then there's a falling and a rising edge. These are the software flag that we created as a way to filter out the noise from the mechanical button on these receiver. And I also will go in depth about it later. And then under here, we are defining all the pins that you guys wire during the last two hardware workshop. So these are the pins that receive the signal from the receiver. So you have the speed input pin, which will basically from your will receive the input from your your button up button and then speed input down, and then we have the right wheel input up, which is from also for all of these are from your receiver on your circuit. And then if you press any or you press any of this the stick here, it will send a signal to one of these pins. Depend on what you press or depends on what stick you pull or push. And as you can see, we are using the analog pin because the reason is because we ran out of the digital pin on the right side of the Arduino for other purposes. So we're using the analog pin, but we still using them as a digital input because analog pin can also still do the digital input pin functions. Okay. So these again is the input pin that Arduino used to receive the signal from external electronic components. And next we have the actual variable that we assign will send to the pin. So there's a difference between the name of the pin or the variable we assign to the pin and the actual value that will we send to the pin. So these are the pin name, but these are the actual value that we will send to the pin. So oh, I'm sorry. The variable above is the value, but these are the still pin number. Um, so these are actually the output pins to the driver. So these are the input that you receive from the receiver, and then these are the output pin that you will send to the driver, based on your input. So these are the speed pin you would send to your driver to control the speed of your ride motors, and these are the direction pin. So direction pin they only go in pair, and they will be both sent to your driver also. And you have a forward pin and a backward pin, and these two pins control the set of motors on your right side. And these pin will always be the value for these pins will always be high or low, and will always be opposite if you want the driver to drive the motors. So if both of the pins are high, then the motor will not rotate, or if the both of those pins are low, the motor will not rotate. But if one of these pins is high and the other pin is low, then you have the motor driving one direction. And if you have one pin is low and the other pin is high, then you have the motor driving the other direction. So that's basically the basic direction control of your motors. And these are the same thing. And again, these are control this also the output to the driver, but on the left side, which control the left motors. And if you look at your schematic, this will match with these output to the driver. So on your schematic, if you look at the Arduino output pins, they will go directly to your driver, motor driver. And these are the pins, the name for the LED pins. And then again, this will match exactly with your schematic. There's RGB LED have three different color pins: red, green, and blue. And if you want them to be any color, just set them to high. So these again are the digital pin that we use on Arduino, and they are connected directly to the LED. So it's 10, 11, and 12. So those are the pin values. Sorry, the name of the pins. And now we're going to the actual value that we're gonna assign to the pin itself. So these are the value for we use for the motors or the driver on the right side. So first we have the speed pin for the driver on the right side to control the speed of the motors on the right side. So these are will be from 0 to 255, because inside the Arduino, the register controlling the value that determine the PWM signal to the motors are 8-bit register. So 8-bit in binary, you can represent from 0 to 255 in decimal. So 8-bit will be 256 256 value, so it's from 0 to 255 basically. Um, and then you will have again the value for the motor forward and backwards pin. And again, these are direction control pins. So you either have them as high or low. So that's why we have them as a boolean type. Because if one is high, the other is low, then motor driving one directions. Again, if low and high, then it's driving the other direction. Basically, so these are the value for the right motors, and these are the value for the driver on the left side. So this is all the variable that we have. And then now talking about the setup. Yeah.
One thing I want to mention is the const in front of the int means that it's a constant. Because these are pins, we don't want them to change in the code. So it's usually good practice to put const in front of it to ensure that they don't change at all, ever. That's super important. And also, for example, these Boolean values, motor forward R and backward R, the initial values are false because we don't want the car to be moving at all on boot up.
Mm-hmm.
Normally, you don't have to assign initial values, I think, but it's good practice
It's a good practice.
Put something in there before at boot up so it has something to use.
Mm-hmm. Okay, and then next is I'm gonna talk about setup functions. And as I said before, the structure of Arduino program is that it go through the setup functions at boot up once, and then it will continuously run the loop function over and over again. So in the setup function is where you want to put all the the direction for your pins, whether you want it to be input output or any beginning setup that you only need to run once. Okay, so now we're gonna set the mode for the pin. So as I said before, these pins are the to receive the signal from the receiver. So these pins are the input pins that input signal into the Arduino. So that's why we set them all to input. Um, and then these set of pins are the pin that output signal to the drivers to control the motors. So these will control the speed and the direction of the motors. So we're gonna have these pins as the output of the Arduino. Okay, so and then again we also have the LED, RGB LED to indicate the color. Sorry, the speed of the car. So at a certain duty cycle speed of the car, you have different color for the RGB LED as a way for you to determine what speed the car is at currently. And these are also outputting from the Arduinos. That's why these are red, blue, and green. I'm sorry, they are output. All right, and then again, as always, we always have a serial dot begin to serial communicate with your computer, just in case you want to debug anything and you want to print them to the serial monitor. Okay, and then now that we finished the setup loop, the setup functions, we will go into the loop functions. Again, these will be run over and over again continuously by the Arduino program. And in this, I will go over the speed control function first. So to go over that, I will switch over to the flowchart.
And really quick, I'm gonna post the code into the general chat so you can go in there and pull it out. It's on our GitHub. So this link will take you straight to the code. But if you go back a few pages in our repository, you'll also see we have our the same flowchart that we're showing here. So you can use that to follow along. So there's the code. You can just copy the whole thing and drop it into your IDE.
Yeah. So again, this is a flowchart for the main loop of the soccer bot. And then first we have the speed control to control the speed of the car. And we have the direction control loop over here. And then eventually we'll have a update motors function to update the value of the pins. So I will go over this flowchart of the speed control first. So inside the speed control, we basically constantly checking the inputs, the speed up input press, and then the speed down input press. So on your receiver, again, you will see an up and down buttons. So what we checking is that we checking whether these buttons are being pressed. So once the button is pressed, then a signal would be sent to either the speed input up or the speed input down, and then a signal will make it high. So the value of this pin will become 1. So when it become 1, then you know that the button is pressed. So you go into the next check, which is the flag check. So what does this flag do? It basically means that uh, you are there's no button pressed before, and now there's a button pressed. So there's gonna be a rising edge from 0 to 1 uh, when you press the button. But in some cases, because these are mechanical devices, there will be mechanical noise. So when you press 1, it doesn't mean that inside it's only press 1. It could be some noises, and it can register multiple presses, even though you only press 1. So we create a software flag uh, to show that when it's press 1, it's go into the state of high. So from low to high. Then when it's at high, it will not register any more press until it finishes doing a job within this function. So if that means that if it's at the low currently and then it detects a press, then it's go into a rising edge and go to the high level, and then now it's at the high. It means that we are at the high, and there will be no more rising edge until we press it again or we finish doing the job. So when it detects a button press, then it will check the current duty cycle or the current speed of the car. And if the current speed is already equal or greater than 100 duty cycle or at max speed, then it will just stay at 100% duty cycle. But if it's not at 100% duty cycle, then you will increment it by 10. So if you say you have a 20% duty cycle, when you press it, it go to 30% duty cycle, and it's basically mean that your speed increased by 10%. So that's basically 10 different level from 0 to 100. Okay, and then after it finished doing the increment of the speed, then it will print out the duty cycle to your serial monitor, just in case you are connecting your Arduino to your computer, and that will let you know what duty cycle is at currently. And then again, it will check both of the buttons. So one is check the speed up button, it will directly go to check the speed down button. And again, if it's detect that you have a button press, then again it will go into a software flag to check that, oh, did you press it actually, or is it the noises? If it the noises, then it will just skip the press itself. But if actually actual press, then it will go into the actual functions to set the speed. Again, it's worked the same way. If you have a duty cycle of 0, that means you have 0 speed, then it would just stay at 0. But if you have a speed higher than 0, like 10, 20, or 90, it would just decrement by 10. Again, it's gonna print the duty cycle again. Okay, and then remember what I said about the register values that store the value for these output pins. They are 8-bit registers, so the value are actually from 0 to 255. But because our PWM duty cycle value is from 0 to 100, so they are not matching. So we need to map the value from 0 to 100 to from 0 to 255, so that they can output the correct PWM duty cycle value. Okay, and after that mapping, if so that they can store the correct value, and after the correct value is stored to the variable here, it will also set the LED colors based on the current duty cycle, and then it will be the end of the speed control function. So if you go into the main function of the code, you can see here. So again, we're gonna use a digital read to constantly read the value of the pin from to say whether it's high or low, because when a button presses become high, right? So when a button is pressed, then you check if is it the noise or not, and if it's not the noise, then you set it to 0 again to make sure that it's basically can detect the next one. And then use 0 pins. These are just debugging purposes, but if you don't connect the computer, it will not show up on your 0 monitor. And then again, checking the duty cycle. If it's greater than 100, then it just set it to 100. But if not, then it's increment by 10. And then again, if it's not being pressed, then it reset it to low level, meaning the rising edge flag is ready for the next press again. Okay, and then the same thing here, which is doing the same thing with the down button, and check the noise, and then set it to 0 if it's already 0, and then you decrement by 10. And then again, if nothing is pressed, then you set it back to 0 to mean that the following edge is ready. Okay, and then here is when you map your duty cycle from your actual range to your desired range. So in this case, we don't map it to from 0 to 255 because we want that at the lowest speed, at 0% duty cycle, you still giving it some some speed, not 0, because at 0 value in the register, it basically 0 speed. But we want that even at 0% duty cycle, you will still have some speed to your car at the least. So we have set the range from 100 to 255 instead of from 0 to 255. And these are the speed value for the left and right motors. And then after that is a LED control function based on the speed. So again, your speed is determined by your duty cycle. So if your duty cycle is less than 30, then we have it a red. If your duty cycle is less than 60, between 30 and 60, you have it as blue. And if your duty cycle is between 60 and 90, you have it a green. And then if it's max speed, which is 100% duty cycle, it will be all will be white, which means that all these pins are high. Okay, and then after the speed control finished, then in the main loop function, it will go into the direction control, and then we'll talk more about it.
All right, so back to our main loop here. So Nick just went over this speed control function here. So once speed control finishes at this end bubble here, it will jump to this end bubble here. It will jump to this selection structure. So typical notation is a diamond for if statements. So this is checking the flag if the wheel input is, it's checking the signal input from the controller receiver if it's 1. And if it's true here, then it will set the flag to forward on the right to true. And then if it's up, then we want the reverse flag to be false because we don't want it to be going backward and forward at the same time. So it can only be one at a time. And once it sets those, it'll move on to print the direction. Again, this is for debugging. It's not necessary. And so that's if it's true. If it's false, then it will check, okay, is it down? And if it's down, then we do the opposite, which is we set the forward flag false and the backward flag true. And then again, it converges to this print statement. And then next, it will check for the left wheel. And same idea, it's going to set the appropriate flags to set the direction. And yeah, I forgot to mention, if it doesn't meet any of this criteria, meaning it's just 0, if both are 0, then we don't do anything, and the car stops because we set both flags to false. And same idea here, except now once it finishes figuring out the direction of both left and right sides, it's going to call the update motors function, which is right here. So the update motors function takes in the flags that we have being manipulated by the selection structure, and it sets the appropriate digital pin to the right value so that the motor controller or the motor driver can actually distribute current the right way. And and then we also have the speed, set motor speeds. This is what actually goes into the PWM register that Nick mentioned. It's taking that variable and copying that over to the register. So now over to the code. So here is the same selection that we have here. It's reading in the right wheel input, and if this is 1, then it executes these lines of code. And if it's false, it will check again, but now on the right wheel input, and it will set these. So this is what corresponds to this part of the flowchart. And then if it doesn't meet both of those, meaning both are 0, then it's going to set both flags to false. And then it jumps down to the same structure here, same idea, just different mappings. And then finally it calls update motors. And this is what update motors looks like. It's just a few digital write statements. This is the pin number that we defined at the very top. And this is the value, the binary value 1 or 0 that we're going to be writing to the output register on the digital pins. And I think that's all.
Yeah. I also want to clarify because you say here it say digital read the pins, and these pins directly correspond to the push or these stick right here. So if you push up the right stick, it will send basically a high signal to this pin right here, and that's how you know it's been detected. And this job is being done by the controller and receiver, and yeah. So just want to have some physical connection to the code, basically. Okay.
Another cool thing, and Nick actually mentioned this before, we're actually using analog pins as digital pins. As we can see here, we have digital read, but on an analog pin, they can both act as analog and digital. You can take an analog pin and be reading a 1 or a 0. Not all Arduinos can do that. I forget which ones, you can look it up. But there are some pins that are reserved for certain functions that can't do this. But in case you run out of digital pins on your next project, you can use digital read. And I think you can write to it as well, if I remember correctly. But that's it for the main code.
Yes. And then once you're done with it, I mean you already have the code, so just write it on your IDE and then just compile it to make sure it's everything run good or like built correctly. Make sure you don't have any syntax error, and then after that you can start uploading that to your Arduino, and it should work if you have the correct schematic wiring.
Yep.
So, for the demo, you can.
Yeah, so, battery fell out. Oh, wait, send it back in. Oh no, where'd the other one go? Oh, it's right here.
And also make sure your controller says the battery as well.
Yeah. So, I forget if we mentioned, but these remotes, funny thing is that they're not actually paired uniquely to your receivers. The way this works is actually, when you turn it on, the receiver picks up the first remote that responds. So it's important that you guys all turn on your remotes one after the other, or else you may actually connect to someone else's car. I thought these were uniquely paired, but they aren't. So it should be working now. So here's ours. So it doesn't explode here. And there you go.
Could you?
Is it coming up? And the white LED there indicates that we're at speed 100. I can start dropping the speed down, and you can see the light starts to change. And we can go really slow if we wanted to, or bump it all the way up. Oh, there we go. And we're back at 100%. All right. So towards the end, we'll go around helping set up, but let's just get to the competition information. So go to that one, and then I'm going to go to Chrome. There we go. So the competition will be taking place Friday, April 28th from 4:30 to 7 p.m. It's in the engineering meadow in front of Building 9. We're going to have a sign-up form to sign up for this event. We also have a little picture describing where this is, so it'll be on there. And so we can bring a soccer ball and compete. There's more information on the form.
Yeah. Also, make sure that if you plan to participate, fill out that form, because if you don't fill out, you would not be able to compete. Because we need the team name and number beforehand so that we can start making the brackets for the tournament. Okay. And yeah, and then there's more detail over here.
So the way it's going to work is that we wanted to have more tables this time around because we have a lot more teams, but we didn't get to doing that. So we have one table, and this is going to be our playing field. It's 1v1, and it's direct elimination. So whoever gets the highest points, they win. It's 3 minutes per match, and the goal is to get, it's basically soccer. The goal is to get a foosball into the other team's goal. And the team with more goals in 3 minutes wins. And as Nick mentioned, it's bracket style, and the winners will get Amazon gift cards. We say cards because I know that we have like a few solo teams, so it could be just one person, it could be 3, depending on how big your team is. And that's all we have for that. Oh, let me.
The bracket and the front attachment.
So, sorry, what?
The front attachment.
Oh yeah. Oops. One last thing we have to give out is the front attachments. This is what will help you hit the foosball. Unfortunately, I think something happened during printing, and the holes are a little too large for the bolts that we provided. So I think on competition day, we're gonna bring some washers to actually put it on. Sorry. If you have any like parts to do it, go ahead and do it. But we were trying to get it done today, or I mean, have it ready by today, but unfortunately we don't. But we'll still give out the hitters. So
I think we all stupid.
okay. So I'm just gonna put it here. You can come up and grab one. The way that these connect is they just sit underneath. They sit right underneath your chassis like this. And we wanted the bolts to go through this, but it's too big and it just falls straight through. So if you have any other way to fasten it, go ahead. But this is what you'll be using to be able to hit your foosball. Okay. One per car. And I will also send out the sign-up form. Please fill it out, as it's the only way that you'll be able to compete. All right, let me know if that works. And I think that's it for the recording.
And then we're gonna start helping all
Yep.
the team with catching up to their design.
So the remainder of the time will be used for catch up. Alrighty, thanks for watching.